Welcome to everyone. Good morning to our participants in the US. Good afternoon and good evening to our participants in Europe and the Middle East. My name is Mohammed Shamsuddin. I'm a digital asset consultant at IPcos here in our HQ in Leuven, Belgium. And I will be hosting this webinar today. So for this webinar, we chose an interesting subject about the manufacturing execution systems and business intelligence in the cloud. With the ever increasing adoption of cloud these days, I think it's important to see what MES vendors and others are offering and what opportunities are there for the process industry. The webinar will be a 45-minute presentation, and it will be followed up by 15-minute Q&A session. You can ask your questions during the presentation in the chat, and we'll try to answer as many questions as possible during the 15 minutes. Finally, I'm glad to introduce today's presenter, Filip Stroobant, Business Unit Manager of Digital here at IPcos. Filip, the floor is all yours.
Thank you, Mohammed, and indeed welcome everyone to the webinar today. So as introduced, we're going to talk about MES and BI, and we'll see how cloud is influencing the developments in those spaces with a particular focus on the chemical industry. So we'll start advancing the presentation. So I think IPcos has been active in a number of process industries for quite some time. So we've been active in the upstream oil and gas business for over 20 years. We have numerous experience in the refining petrochemicals and chemical business, and also in the specialty chemicals business. We have a lot of projects under our belt. And what we will see is that the digital transformation, which is taking place in each of those verticals, is taking some different, I would say, evolutions because of the different specific situations that we find there. And I think today, as we are talking about MES and cloud and BI, we will see how these different environments are adopting those technologies in a different kind of way and at different speeds also. So it's maybe important to also reiterate that IPcos is a technology independent provider of services. So we have no, I would say, inclination or preference for one or the other technologies. We have no economical interests, and hence we're generally trying to seek a neutral perspective. So mainly looking at functionality, looking at customer satisfaction, and so on. Yeah. Now, if you look at digitalization in the process industry, what we are seeing is that this is happening in many different sort of places of the organization. And this whole digital movement is really a wide-scale movement, which is being instilled top-down in the majority of the companies that we see. And you can see that there are implications for the plant side, where actually the money is made, in the control room, on the floor of the different plants. There's definitely a digitalization wave taking place. And all the way up to the corporate, where corporates are typically interested in performance reporting, standard reporting, performance management, and then all the roles which are sort of in the middle there, engineering roles which are looking at operational performance and so on. So the digital initiatives are really spanning across all these different roles. And what we will see is that the digital infrastructure that we need to support all these initiatives is also very, very broad. And this is especially where cloud actually may play a role, and where also the interaction with MES and BI will be important. So, and yeah, we will be showing examples in different sort of spaces, and we will show how these different digital initiatives are playing at each of those places. Now, maybe to start, before we dive into the cloud subject, it's maybe good to understand what is a bit the legacy that we're working with. Obviously, all the digital initiatives which are starting do not do that in a vacuum. There's always a legacy, and what we are seeing is that there are sort of two disparate universes from a data perspective. You have the OT domain, where everything revolves around real-time data, sensor data, and more recently, sensor data, which was typically identified by tags, has been sort of augmented with metadata, attributes, and also put into hierarchies to better model, I would say, the physical infrastructure, the equipment, the pumps, the units in the plants. And that's what we would call the OT domain. Obviously, the domain is much broader, but from a data source perspective, you could argue this is the dominant direction. And in parallel, what we were seeing is the IT domain, where data comes in a different shape. Data comes typically in tables, in columns, rows. Data is not updated live generally, so the time frame is a bit different. Frequencies are somewhat lower. And the emphasis usually is on the relationship between the different data sets, the relationships between tables, and the views that you can create. So the data universe looks quite different. And this is important because the toolkits that have been developed on the OT or IT side have also been adapted to these different data structures. And I think sort of the holy grail that people have been looking for is this unified application that combines IT data, OT data, and then shows everything in an integrated fashion. And unfortunately, we haven't found that holy grail yet. But it's an important legacy. And in every digital initiative, you have to deal with OT data space and the IT data space. And obviously, there's other forms of data like unstructured and file-based, but they are less, I would say, core to the problem here. So the core problem is those two data sets. And you could argue for data analytics, it's a bit similar. Also there, data analytics, which is an integral part of the digitalization in OT, has also taken a different shape. There we are seeing obviously applications which are heavily looking at the real-time data, the dynamic responses, the patterns that we see in the data. If you think about vendors like Seek or Trendminer, they have developed applications which are very strong in data analytics, but very focused on the pattern itself and on the data, the real-time data signature actually. Looking at the IT domain, let's say the business domain, we see different kinds of developments. A lot of focus on, again, think about the tabular data. So we're looking at multivariate regression. So which column is influencing what other column is more the problem you're looking at. And the kind of solutions that have developed there are also different. A lot of emphasis there also on variability analysis, looking at reducing variability. And you could argue also there we see somewhat a parallel development. This doesn't mean that there is no tabular data used in the OT domain, but it's still, I would say, dominantly segregated. Another element which I think is worth mentioning is, and this is not new, but the data science community. So people looking at data analytics in the broadest sense have adopted more and more open source. And you can really see a standardization towards Python and R and the associated notebooks for developing, I would say, algorithms and doing proof of concepts and really developing these applications and subsequently also deploying them in real life. So this is also an important trend that we are seeing. It's also what I would call part of the legacy here. And then there was cloud. So, and if I say then there was cloud, it's not that cloud was invented yesterday, of course. I mean, cloud has been around for quite some time. And you may wonder, well, why now a webinar on cloud and MES and BI? I mean, what is changing? And this is especially the topic of today, trying to point you to some of the evolutions and trends that we're observing and which may impact the solution space in digital related to IT OT data. And you can see here, cloud was already launched here, and the exact timeline is not important, but it's just important to understand that we're already looking at cloud for over a decade right now. But the spending and attention to cloud is clearly increasing. So, and you could say, well, I'm using Office 365. Okay, what does it matter to my MES digital program? And this is really the question that we try to answer today. And I think to start, it's maybe good to first get the definition straight. Cloud can mean very many different things, and this is part of the reason why, well, cloud has been around for some time, and we've seen cloud all over. But okay, we may have seen it in different forms and shapes. And I think the starting position here is to look at infrastructure as a service, and this has been around for quite some time. And this is mainly dominated by a number of major providers, Amazon, Microsoft with Azure, Google. They are the major providers of infrastructure as a service, and the implication, I would say, for end users or data scientists of this infrastructure service is not so crucial, because it really has no impact on the end user application. It has no functional, I would say, impact, but it's a very important IT evolution, and it obviously has impact on how the infrastructure will be governed. And there's also an element of cost. So the whole point of infrastructure as a service is the scalability of the infrastructure and the fact that you may only need to pay for what you use. Whereas if you put your own infrastructure in place, you're going to design it for the maximum possible load that you may expect. Whereas here in a shared infrastructure, you're going to be able to say, okay, I'm going to scale the infrastructure as I need. If I run a very heavy optimization only once a day, I'm only going to pay for the compute services then. I'm not going to have to pay for that continuously. So there are some implications there for IT, but they are less, I would say, important for the end user. And that's obviously very different if you think about software as a service, which is sort of the other extreme. In the software as a service case, it's not just the IT infrastructure which is managed externally, but it's now also the end user application. And it means that for you as a client, you don't have to worry about upgrading versions of the application or installing the application or any of that. This is actually fully managed by the vendor actually here. And this also has functional implications, because it means that the way you're going to use the application will maybe quite different. It may be accessible from anywhere on the internet. It may be accessible as an app on your phone. It may be accessible through any kind of browser that you have. So it really is kind of a game changer compared to traditional application deployment on traditional architectures. And you can see here there's a number of vendors I'm listing here. Obviously, Office 365, you may say, well, it's not really important, but this is becoming a de facto standard. So we have made that transformation already in our sort of Office environment. But now you will see that a lot of the other vendors which are playing in the analytics and advanced analytics space are moving in this direction. And this is something we have to account for. Now, there's also this intermediary platform as a service concept, which is effectively some sort of middle ground where you may not find your end user application hosted on the cloud and managed by cloud providers, but it's really different building blocks of the application which are now available on the cloud. Some examples, you see InfluxDB, Snowflake. These are databases for real-time or for relational data, which are hosted and managed entirely on the cloud. You could say, well, why is that platform and not software? Well, it's really platform because the databases as such do not provide you with end-user functionality. They're typically integrated in bigger applications. They may be connected to other applications, which are then software as a service enabled. So this is not unimportant, because in the architectures that we will see evolve, there's an enormous number of platform services that will be at play and that will be important. So this intermediary step may prove to be very, very important. And also, platform services are important when you're into the game of custom development, when you want to develop new applications. And leveraging some of these platform services, or leveraging database services or analytics services which are enabled on the cloud, while you really consume the platform for developing the actual application. So this is important to get the definition straight. And now IoT, what does IoT add to all of this? So, well, IoT is another paradigm which allows you to bring data to the digital infrastructure at a low cost. So traditionally, you would have had the sensor, you would have to wire it up to a SCADA server, OPC server that goes up to potentially an enterprise historian or a local historian, and then, okay, you can make it available to your end users. And that could prove to be quite costly, because every step that you take in that whole architecture will cost you some. And it's proven in many cases it's not cost effective actually to go for that full digitalization. So with IoT, we're actually shortening that route, and we're actually finding shortcuts from sensor data all the way into your application space. or cloud using a special architecture, using public internet, or using wireless infrastructure which you have available privately. And what you see here are a couple of stages which are quite typical for an IoT architecture. So the sensors that we're talking about are very much the same sensors as you have in your traditional architecture. But now we're seeing these new gateways emerge which connect the sensors in and then have a straight connection into a cloud service. And on the cloud, we're back into the story that we were before. There are some PaaS services, so platform services, which will allow you to automatically register different devices, store the data maybe in one go, and also manage the metadata. So when you would add a new IoT sensor, the platform service will automatically discover that new sensor, will automatically provision a data store for it, and also add the necessary metadata, obviously assuming there is a sort of security contract between the two entities. But this is a very efficient way to bring new data into your digital infrastructure. And this architecture is completely bypassing the MES layer. And this is important because whenever you embark on an IoT strategy, immediately that question will come on, wow, what about my traditional MES layer? Because now there is data in my infrastructure that I'm not seeing anymore at the MES level because I've just bypassed it. So immediately you'll have to answer the question, well, at what level do we have to develop further functionality if we want to have full visibility, or do we need to replicate the data back into the MES layer? But okay, then we obviously we'll lose some of the efficiency gains. Yeah. In some cases, there's also a good case to make for what we call edge analytics or edge processing. So if the data is high in bandwidth or high in volume, there may be a case to process the data locally, so these local edge devices, or there may be edge compute services, edge meaning on the site, which would reduce the dimension of the data to make it a more efficient process, sending the data up to the cloud. So I think this IoT in combination with cloud is really what would be referred to as Industry 4.0 architecture, and it's those two concepts that we really have to think about if we're talking about modern architectures. It's those two concepts. Now, the first thing we may want to look at is, okay, what are the MES vendors doing? If you look at the process industry, the lion's share of MES is driven by Aspen and OSIsoft, especially at the higher levels in the MES architecture. So enterprise historians are for a large part driven by those two vendors, especially in the chemicals and upstream business. And you can wonder, well, what are they doing? How are they responding to this whole cloud movement? And we see different things happening. Aspen, for example, has a bit of a dual strategy. On the one hand, they're developing software as a service applications, so straight in the cloud native applications, which actually are focusing on performance management, on advanced trending functionality. But obviously, Aspen has an enormous legacy of MES applications, and it's not so easy for them to migrate that all at once into an entire SaaS offering. So what we are seeing here is also a migration of the traditional MES stack into the cloud infrastructure. So you can see here, there's what we call MES, so IP21 Enterprise, for example, there's A1PE, the visualization layer on top. Well, all of these modules are now available in the cloud, but they're not truly a SaaS offering. They're merely hosted on cloud infrastructure, and then there's connectors in place, Aspen connectors, to hook up the different, I would say, modules with each other, to hook up the MES layer that you may have to that cloud infrastructure, or connect the native cloud applications with what you're seeing here as a traditional stack. Yeah. So here it means that you may need to still manage the MES applications, but you're doing it on cloud-enabled infrastructure. Yeah. Whereas here, well, you'll not have to deal with any Aspen software anymore. This will be done entirely by Aspen itself. So parallel development. OSIsoft is a little bit different. OSIsoft obviously has the historian. There's also a nice development around metadata using things like AF. There's also an edge strategy which OSIsoft is supporting. But what OSIsoft does not have is a very developed MES application layer. It's very different from what Aspen has in that respect. And what Osisoft has done right now, it's developed what we call, well, what is OCS, Osisoft Cloud Services, which you could see as a sort of a platform service, which offers the data or some of the data that you've collected in your traditional MES layers and offers that to other cloud applications. So this is more the platform idea. It's not really offering much end user functionality, but it's really providing the data to other actors which are active on the cloud. It could be custom developed or third-party applications which are native to the cloud. Now, one caveat for Osisoft. Osisoft was obviously acquired by Aviva not so long ago, and Aviva has its own cloud strategy, and we will be watching, obviously, how that integration will take place, and there will be definitely some interesting developments there. Now, what we also want to look at is what is Microsoft doing? And as I'm telling the story, Microsoft, you can also think about Amazon. I mean, the story is very much similar. But what is very interesting is that Microsoft is now developing an end-to-end architecture where many of those ingredients that we have talked about are actually available. You look at the left-hand side, you see that whole IoT architecture here. You see the edge pieces, so anything that has to do with edge compute and analytics, which are local to the device on the side. You have the IoT hub, which is effectively the gateway from your edge into the cloud infrastructure. Yeah. So, and the whole device management. So the platform service we were talking about is obviously natively offered here by Microsoft. You see here the module Azure Digital Twins, which is everything around modeling that data. And this is kind of interesting. It's not using a hierarchy or a set of linked tables. It's actually using a fairly flexible graph model, which should allow you to model sort of any kind of relationship, and which is really the platform of choice for Microsoft to model, to become your digital twin of the actual site or factory or whatever you're trying to model here. So also that data modeling piece and contextualization of the data is now available here. And then in the architecture, you see sort of three paths here, so cold, hot, and warm. And you could see this a bit as the IT-OT split that I talked about in the beginning. So everything they call cold means low frequency update. This is data which is relatively static, maybe daily data, monthly data, data which is not moving very quickly. And warm data is the data, or hot and warm data is data that has higher frequencies, higher updates. And you see that there are services available, platform services you could call them, and some of them are SaaS services, which deal with processing and managing the real-time data at these different levels. You also see Azure ML here, which is a platform service offering analytics capability for the cold data. Yeah, for the real-time data, we're talking about streaming analytics, which is also available here. So you can see already, like, okay, there is new modules available here on the cloud native applications, which definitely have significant overlap with functionalities we would have seen in MES or in, I would say, the business domain before. And then last but not least, there is the whole application space. You could see this as your SaaS layer. These are the end user applications. You see 365 here, and you could say, well, what's the relevance of 365 in this cloud offering? Well, let's not forget that the most popular application ever used in any sort of process industry, I wouldn't say control room, but in most, I would say, user roles is Excel. Excel is the tool of choice for many people, and you could argue, well, the comeback of Excel could be here. Let's maybe hope not. But there are other, obviously, applications that are natively offered here that now have immediate access to the different data sources which are available here. So you see how the paradigm is shifting, and how the sort of disparate development, MES, IT, OT, sort of is coming together here in an integrated architecture. It's also important to mention that Microsoft, but also Amazon, obviously has a marketplace where other third-party vendors can offer functionality. So other SaaS offerings can obviously be integrated here, connecting to the same data sources that we have here. And to make that a bit more real, I'm showing you two Microsoft modules. On the left-hand side, you see the time series insights module. which is a fairly basic trending module, where you're looking at the number of sensors with some metadata, some real-time data, some zooming capability. Nothing very fancy, but you could say there is overlap here with some basic trending capabilities that we find in the MES layer traditionally, thinking about by process book or by vision. There is clearly some overlap here. Also, the data model that we were talking about, the digital twin, the metadata, the structure is available here. So what's even more, Power BI allows you to combine real-time data sets with the traditional relational data sets. So you could even say this is taking it one step further. And we now have exposed the real-time data sets, let's call it the warm pad or the hot pad, with the relational data, which is more, as we would call it, cold. So this is presenting new opportunities, and there are definitely business needs. Remember, we were talking about this holy grail. I'm not saying that Power BI is the holy grail, because there's enough IT people saying that, but it is definitely a trend to watch. It's definitely something to watch. Now, enough for the theory. Let's now have a look at the process industry, and where are now the opportunities? Because the last thing we want to say here is like, oh, let's move cloud everything and now. So there is definitely a trend, and we want to really look at the opportunities and look at it a bit case by case. And the first thing I want to point to, and is something that we are seeing in our projects, is that the concepts we've talked about, IoT, cloud, are definitely an enabler for accelerated digital transformation, especially for smaller production sites. And this is an important distinction. Why is this a distinction? But what we're seeing is bigger sites, so very high capex sites, are usually already very much digitalized. The MES layers are very well developed. There's a lot of investment that has been made before in improving the performance of these sites. So it's very hard to make a claim that now adding a cloud or IoT architecture on top of this is going to make the difference. I'm not saying it couldn't, but for smaller sites where these investments have not taken place yet, and where actually a lot of the operation is sort of, it's maybe digital, but it's very local digital, and maybe part of a legacy MES system, which is not very open or not very scalable. There is an enormous opportunity here to accelerate this. And the acceleration usually comes from the fact that you're finding a way to connect the legacy MES layer, the legacy MES data, with a cloud infrastructure, which is then managed a bit more centrally, and where now you're opening up opportunity for optimization, advanced reporting, OEE, so performance management. There's lots of, I would say, opportunities that now emerge. And you can imagine if you wanted to implement advanced performance management applications on top of a legacy MES solution, that would be very, very painful, and you would even struggle to find actually the applications that still run on Windows XP, to give an example. So there is definitely an opportunity here to accelerate, and we see the same in upstream. In upstream, we see exactly the same, and this is a bit of a typical example. So well production is typically done from large distributed areas, and each of those individual wells may not be very well instrumented and will not have all remote controllers and full-blown digital infrastructure. Actually, some of these wells will be completely blind. And also here, there is an enormous opportunity to accelerate digitalization. For example, here, this is a well where you have an electrical cabinet, and before, this electrical cabinet was quite dumb. It was really providing power to the well, providing power to the motor, but there is absolutely no visibility from this well back to the central office. And actually, the installation of a central gateway here has enabled, well, advanced surveillance. It has enabled the development of soft sensors. It has enabled exception-based surveillance on these wells at a fairly minimal cost. These gateways are coming straight out of the shop. These are maybe $200, $300, so that this can be done very cost effectively. And then obviously the infrastructure you need on the cloud side is more pay as you use. And the other opportunities that we see here is to improve safety using video analytics. There's also nice opportunities if you have video streams available and you use analytics available in the cloud. Typically, this will be neural networks which are trained already. You don't have to do that yourself. They may be trained to identify people, or they may be trained to spot the use of PPE or not. And so these are very interesting, I would say, opportunities which you may or may not want to pursue. Another opportunity that we see is, as we talked about the cloud and the fact that in the cloud you may be combining data from the different domains. So this IT data coming together, OT data is coming together along with its metadata. And now you may wonder, but okay, how can I now present this data back to the different roles in the organization? Because every role will have its own data needs. Data scientist wants to see data in a certain shape or form. Maybe an HSE or maintenance engineer has different needs. How can I now leverage this for all these different roles? And one of the very important opportunities and requirements is to really think about how do you want to develop the data catalog here? How am I going to structure this data, and how am I going to expose this data to these different roles? And this is a very difficult undertaking, and it can take quite some time because yeah, it requires you to think about how data from all the different sources combines together and maps onto each other to come back with a sort of logical model, a model that can be browsed and that can be consumed by a whole variety of engineers and HSE managers and plant managers. So, and one of the very important points here is that it's key to also bring the metadata to the cloud and not just the data itself. So, and metadata can even be generated in the MES layer. So if you've developed an asset model already at the MES, as part of your MES project, it's obviously important to then replicate that and reuse that further up in your architecture and as part of your data modeling project. The same for DCS configurations, the same for catalogs that may have developed, for example, on top of SAP or ERP databases. So that metadata has to be migrated upwards and integrated for then the development of the data catalog. Yeah, and these are very important, I would say, initiatives to bring the data to life and make it usable and accessible, and maybe also push Excel a bit out of the equation for a lot of the use cases it's used for today. Last but not least, I want to point to the connection between digitalization and sustainability. And obviously, this is the right time to talk about this. So it's kind of clear that there's an important corporate responsibility to look at the emissions of your process. We're obviously talking about CO2, but also other, I would say, emittents have to be looked at and reported. And obviously, as we can expect, that there's going to be more and more scrutiny on how this reporting is done, and there are already quite a number of European regulations in place that actually tell us how that has to be done. And I think companies are exposed to more and more liability if they don't do it the way it should be done. And there's also a clear economical impact with the whole ETS system, as CO2 coming at a certain cost. So you can imagine that for corporates where typically, this whole problem is also tackled, the cloud infrastructure and the opportunity to really standardize the reporting can provide you an opportunity to address this. And an additional opportunity that the cloud brings here is that there may be a need or an opportunity to integrate data which is coming from outside of your organization, because maybe you'll have to also report emissions or data from some of your suppliers, because maybe some of the emissions are generated by your suppliers. The whole end-to-end, I would say, value chain is looked at. You may have to integrate data from outside, and the cloud is obviously, or cloud infrastructure is a very good mechanism to achieve this. So we see also an important trend here in this domain. Okay, so far for the opportunities, but there are obviously some caveats also. It's not so clear cut, and there are possibly some reasons why the development into cloud may be stopped or slowed down, or there may still be discussion. And what are those? First of all, there's the element of data security. And it's very important, obviously, that the organization and the company that you work for is ready to push its process data to a cloud environment. And it's not so trivial, of course. Process data is extremely sensitive data usually, and there may be corporate policies or other policies or regulations that prevent you from doing this. So that is obviously step 0. Step 1. Is there sufficient buy-in from the management and the IT departments, and is everything in place to actually move some of your data to the cloud? This is obviously the first step. A second step that I want to point to is cloud is by nature a very central initiative. It's typically driven centrally. IT has a very strong involvement. You could argue a bit stronger than what you would see in traditional MES or local initiatives, because well, it's not something you will set up from site, right? You'll do it from a corporate perspective. But what we should not forget is that the agility that we need towards the different sites has to be maintained. Sites have specific needs. If you like it or not, you may say, oh, well, we have a standard performance management solution. That could be the theory, but the practice will be that every site has its own practices, its own needs. So you have to maintain that agility. And so I think the governance that you need to put in place between whoever is managing your cloud infrastructure or cloud platform or even cloud solutions has to be ready to show the agility needed to keep the end users happy. The end users are usually the people running around on a site. They may be physically, but also mentally quite far away from the people who are driving those cloud initiatives. And this is a real challenge, I think, that needs to be addressed going forward. Otherwise, we'll see a lot of disconnect and a lot of, I would say, failed initiatives happening. A third element, which is also worth looking at, is also how to avoid vendor lock-in. I've shown you that Microsoft architecture that goes end to end, and that looks a bit scary. If you look at it from a vendor lock-in perspective, all of a sudden your whole database infrastructure, your data model, your analytics, I mean, it's all living off the same platform. So it's really a risk that you have to manage. There are multi-cloud strategies that address this, but it's really something that you need to think about. And obviously, there is also agility in using other vendors on top of your cloud infrastructure to sort of reduce the risk, but it's definitely something to watch. You do not want to put all your eggs in one basket, as we would say. What are the further future developments to be watched? Because I think it's really a sort of moving target, and we are seeing announcements almost every week by the major vendors on developments in this space. I think one of the major things that we are watching is the traditional MES historian, which is mainly a tool used within the office environment by the engineers, but also somewhat by operations, but mostly by the engineering community. Will this be further challenged by cloud-enabled data stores, platform services that will be developed further? And will we see more and more data live at the cloud, on the cloud side, rather than at the MES layer? For example, by accelerated IoT initiatives or other initiatives. This is one trend we are definitely watching. And secondly, how are the applications which are developing on the cloud challenging the MES functionality? Obviously, what I've shown with time series insights is just trending, right? I mean, you cannot say, oh, now we're going to do away our full MES layer like planning and scheduling and so on. That's not realistic. But on the other hand, you do see that companies like Microsoft, but also Amazon, are dead serious about getting a stronger foothold in the industrial, I would say, space. This is absolutely clear. And we may expect further developments in that space. And also that is something that may further, I would say, shift the equilibrium that I'm showing here today. This is something to watch. And I'm now ready to actually start concluding the presentation of today. And basically, the main points, the main takeaways I would actually want to give you is, well, first of all, that cloud developments are progressing. The landscape is moving, and it's moving fast. And it's undeniable that there are overlaps between some PaaS solutions, SaaS solutions with traditional MES. And it's almost impossible not to think about that equilibrium in your organization. It has to be looked at. And a sort of optimal, I would say, setup has to be thought about, and maybe a roadmap has to be thought about as well, because this is moving. Secondly, integration of IT and OT data. So this holy grail of integrated dashboards, looking at everything in one go, is definitely an opportunity. but the data management challenge remains. So bringing more data together makes the data integration challenge more difficult and has to be addressed. So there is an opportunity, but there is a lot of work to be done on the contextualizing of the data, the mapping of the data, and making the data usable in that combination. It's very much important. And last but not least, as I mentioned, less technical argument, watch out with governance. Let's not make these IT projects that are completely disconnected from the business, and keep the sites on board, because yeah, that's effectively where the money is made in the end. Yeah. So yeah, that's all I had for today, and the floor is now open for questions.
Okay, thank you, Philip. I have a few questions. So we have a question. Our organization has a number of small sites with just SCADA systems in place. So for the digital transformation initiatives related to these sites, where do you recommend we start?
Well, yeah, I think the main advice is to start from the business priorities, right? I mean, a digital strategy, you could argue, well, it's strategic, we have to do it anyway. But that's one way of looking at it, and this is somewhat viable because everyone is taking this direction. But the approach we would always advocate is to look at the business priorities, and then from that develop a digital architecture that serves it. So it's in that order. What we really would want to avoid is digital initiatives looking for problems. So usually you have sufficient problems already, so try to turn that around and set your priorities from a business perspective. If you say, for example, well, we have all these sites, but we're lacking the visibility, we do not have the I would say performance management tools in place to effectively steer decisions or OPEX for these different sites, well, then that should be the leading, I would say, that should be leading in your decision to then drive an IoT strategy. So, and then as you develop this, you can then take it as a starting point and gradually develop it from there. So we think a big bang approach is not sensible, and it's something that has to develop from early successes and then grow as you go.
Yeah, indeed. Yeah, if you have any questions, you can use the Q&A section to ask your questions. Another question I have, thanks, Philip, excellent presentation and outlook. What is your opinion of the advantages of graph models or the technology of choice to implement an asset model in cloud architectures?
Yeah,
I think it's related to implementation of asset models and cloud architecture.
yeah, I think that the graph model is interesting, and I think it can address some of the modeling challenge. But what we believe is the data modeling challenge has to be solved at sort of different levels, and we believe that it's actually ultimately what's gonna we're gonna end up with is an overarching data model, call it the digital twin, which sort of models sort of the high level enterprise structure, and which then links into that the data models of the sort of detailed domains that are living underneath. If you go to ERP, well, SAP has its own data model. It's actually fully developed, but it can never be the master model because it's only looking at ERP type of data. Real-time data is also modeled already, usually using, as we discussed, tree views. We don't want to do away with them. We really want to link them into a master structure so that actually bridges are built between those different universes. And I think the graph model can be an interesting technique to accommodate this, but it's definitely not the only one. There are other, I would say, solutions, and you'll see if you look at the marketplace, there are many solutions that are looking at overall data modeling. And I would say we are also watching the space a bit there of, okay, what direction is this taking? But it's really not just one solution that will do the trick. It's really, again, the combination and the integration of different initiatives which have played at the lower level. And why I'm saying the lower level, again, you have to solve data modeling problems at the right level, namely at the domain level. It's the HSE specialist that can actually model HSE data. It's the, I would say, ERP specialist that can really look at the data model at that level. If you bring it to the level up, there is no one that can master the entire universe. So make it a staged problem, and graphs can be a nice addition into that.
Another question I have, very interesting and insightful presentation. Thanks. You talk about the challenges of moving in this direction. What is your advice for companies on how to organize such a cloud MES initiative? Specifically, what organizational roles are key, new and existing?
Yeah, I think that's a good question, and I believe it goes back to what we said before. It's looking at your business priorities. So projects can only be successful if there's a true business need, and obviously, what I would look at is who are the business representatives who have the biggest interest in this digital initiative. If we think about the examples I gave, think about corporate emission reporting. That could be an HSE initiative. If this is really, really important in your company and you say, look, this is maybe a good starting point, it's obviously those business representatives that have to be involved. But obviously, they will not be able to do this by themselves. You may have to complement this with a group, a digital group. I mean, many companies are effectively organizing around digital and saying, hey, there is digital expertise grouped or centralized in a certain group, which are people who know very much about, okay, these architectures and cloud and how to actually set it up. And it's effectively then from that combination that you're going to be successful. It's the combination of business reps and then the digital specialists that are coming together. In some cases, when you have analytically complex problems to solve, you may think of a data science community to be integrated as well. And obviously, your IT department, if that's not part of your digital initiative, your traditional IT department or MES department may be involved to support the transfer of data from legacy systems into the new architecture. But again, think about the business first. What are your business priorities, and get those representatives involved? Because digital can never be successful if it's on its own track. It has to start integrating more and more with your normal business lines. This is the only way it can work. And there are numerous examples where that has gone wrong, and I hope we are sort of past that stage.
Okay. And another question. Also, if you have further questions, please ask in the Q&A section. Thank you, Filip, for the presentation. Do you think that big cloud providers, AWS, Azure, Cloud, Google, are competing with traditional MES vendors in their own spaces? And what do you think they are bringing to the table?
Yeah, competing, I think that they obviously companies like Amazon and Microsoft have very generic strategies. And if you think about the idea of real-time data, so why are they now getting more into real-time data? It's because real-time data is everywhere. It's not only in the process industry, but with the self-driving car, in finance. I mean, there is real-time data in an intelligent building. So real-time data is everywhere, and the digital movement is not happening only in process industry; it's happening everywhere. So it's quite clear that there is an interest from Microsoft, but Amazon, also for Amazon, to sort of mature the infrastructure dealing with real-time data in the broadest possible sense. And so I'm not expecting a Microsoft to compete with a planning and scheduling application from Aspen tomorrow. I don't see that happening. That would be very deep down into the vertical. But you may see more and more overlap from generic real-time functionality, things that you would not find in Excel or Power BI or a BI tool before, like basic trending, basic zooming, history, looking back into history. So these kind of generic real-time functionalities, eventing, alerting, these are very generic concepts. And they may inadvertently compete with the more, I would say, basic MES functionalities that we have seen before. So I think it's more that what I would expect rather than a deep down competition on specific applications. But that overlap will grow. Yeah.
No, I still have one question in the pipeline. If more people want to ask, please do that in the Q&A. So it mentions security for us is an important factor when deciding to move to cloud, especially MES applications. What is your take on the security practices by the big cloud vendors? And would that add additional risk to our network compared to on-premise solutions?
Yeah, I think security, it's very difficult to objectively evaluate security, right? It's actually true for every type of risk. There's usually you don't have enough samples, I would say, to characterize the risk. And so I think in returns, one of the things you have to think about is obviously when you're using a cloud service from an external provider, you're obviously putting your eggs in the basket of that provider. It's the same as we are. We're on Office 365. That means email security is not in our own hands anymore. We have actually transferred that to Microsoft. And I have the feeling everyone is sort of okay with that. And I think that the question you have to ask yourself is if you have on-prem infrastructure and you want to do digital, because obviously you could say, well, I have on-prem MES, but I'm actually completely disconnecting this from the outside world. I'm not allowing for any data to stream upwards in the architecture. Well, that will be very, very safe, but it's not going to be very, very digital, or it's going to be very painful to be digital in that sort of context. So if you're actually assuming you're going to go digital, then you have to wonder, is your own IT department better placed to secure that architecture than actually the major providers for whom this is really their bread and butter and where the reputation is obviously on the line? So it's really that comparison you have to make. You have to really see, is that making things better or is it making things worse? And again, this can really depend. This is case by case. Also, it's maybe good to point out that today we are talking about one-way traffic. We have not talked about closing the loop. We've not talked about changing or set points or valve positions from a cloud algorithm at the moment, even though those architectures do exist. The majority of the initiatives that we are seeing right now are one-way traffic. Now you could argue if you have a secure one-way channel, the risks of, I would say, production interrupts and process interrupts have obviously greatly reduced. And in that respect, we think that it has to be seriously evaluated whether it's appropriate. I don't think it's too easy to say it's just simply not secure. It has to be evaluated case by case, and you have to compare it with the security that you have right now, which is also absolutely not 100%.
Excellent. I think that's it for the Q&A. I would like to thank everyone for participating in the webinar today. We will be uploading the video to YouTube and share the link with you. So if you want to watch it again or share it with your colleagues, and if you want the PDF of the presentation, just send us an email. And we look forward to seeing you in future webinars. Take care.
Thank you all. Thanks, Mohammed.
Bye.